So बच्चों, let's read this question. The question says if the bond energies of H single bond H, Br single bond Br and H single bond Br are 433, 192 and 364 kilojoule per mole respectively, the delta H naught, that is standard change in enthalpy for the reaction H2 gas reacts with Br2 gas to form 2HBr gas is, we have four options. They are A, B, C and D, where A says plus 103 kilojoules, B is plus 261 kilojoules, C is minus 103 kilojoules and D is minus 261 kilojoules. Key concept involved in this question. So the key concept involved in this question is calculation of delta H naught, that is standard change in enthalpy for a reaction given. So this is the reaction given, that is H2 plus Br2 gives 2HBr using bond energies. So bond energies are given in the question. So enthalpy change is determined by, that is delta H naught is determined by formula, that is total energy required to break bonds minus total energy required in forming bonds. So this total energy to break bonds and total energy in forming bonds, that we need to calculate. So first we'll see what are there at the reactant side. So at reactant side we have H2 and Br2. So H2 is written as hydrogen single bond hydrogen and Br2 is written as Br single bond hydrogen. So we need to break these two bonds. So break these two bonds in order to form the product. Now we'll see at the product side. So at product side we have two HBr molecules. So HBr can be written as H and Br. So we'll be forming two H single bond. So these bonds are formed. Two such bonds are formed in the product side. So now we'll try to calculate the energy required to break HH bond and Br bond and energy required to break to form HBr bond. Write the given data from the question. So bond energies दिया गया है. Bond energies of hydrogen bond is given as 433 kilojoule per mole. Then Br single bond Br is given as 192 kilojoule per mole. Then hydrogen single bond Br is given as 364 kilojoule per mole. So now we'll be using these values to calculate total energy required to break bonds in the reactant side. To break bonds in reactants. So we have HH bond, H2 and Br2 at reactant side. Therefore, it will be 433 plus 192 kilojoule per mole. So this will be the total energy to break bonds. Now we'll be calculating total energy required to form bonds in product. So this will be, at product side we have 2 HBr molecules. Therefore 2 into 364 kilojoule per mole. So now with this we can easily calculate delta H naught. So therefore delta H naught is equal to 625. Upon adding the values, it will be 625 minus 728 kilojoule per mole. So if we solve this, it will come as 103 kilojoule per mole. Therefore, delta H naught has come out to be minus 103 kilojoule per mole. So based on this, we can clearly say that option C, which is minus 103 kilojoule, is the correct answer for this question. Hope you all have understood. All the best.